Hi. So I hope we are live right now, and all of you are able to join. Uh, yeah. Hi. So all those who are there out there, um, can you hear me? Just yes. A very good morning to all of you. Those who are joining live, आप सभी को सुप्रभात और अम, रामनवमी की बहुत बहुत बधाई सबको। और आज हम डबल इंटीग्रेशन सीखने वाले हैं पोलर कोऑर्डिनेट्स में। सो आपको मेरी आवाज़ सुनाई दे रही है तो आप मुझे खाली एक बार चैट में यस बता दीजिए तो हम आगे बढ़ते हैं इसके लिए। हेलो, एम आई ऑडिबल टू यू? मेरी आवाज़ आ रही है? ओके, या फाइन। हेलो, थैंक यू, थैंक यू। So see, I'm going to do polar coordinate thing, and this will be a bit mix. I will be writing notes as well as it would be a mix of both. Okay, so yeah, just hold on. Let this thing open. Yeah. So yeah, yeah. Here we are going to start double integration in polar form. Now, while doing double integration in polar form, all of you, खाली आपको इतना याद रखना है कि इसमें कोई ये भी एक फैसिलिटी है लाइक चेंज ऑफ ऑर्डर। जिन लोगों ने चेंज ऑफ ऑर्डर सीखा है वो ध्यान रखें। या गुड मॉर्निंग टू ऑल ऑफ यू दोज आर ज्वाइनिंग, प्लीज़ आस्क ऑल ऑफ योर फ्रेंड्स टू ज्वाइन। तो जितने ज़्यादा लोग ज़्यादा से ज़्यादा बेनिफिट कर पाए ये उसके लिए लेक्चर है। अच्छा, और मेरा मेन मोटिव ये लेक्चर का मैं आपको बताना चाहूँगा कि इट इज़ दैट यू शुड बी एबल टू सॉल्व इंडिपेंडेंटली। Okay, once you attend all these lectures and see all these different types of problems, you should be able to solve independently on your own any unseen question. Seen and unseen both you should be able to do. That confidence of solving the problem on your own is the sheer joy that we are working for. Okay, तो ऐसा नहीं है कि आप खाली आए और बस देखा सॉल्व किया लिख के चले गए। ऐसा नहीं करना है। आप सोचिए, शांति से सॉल्व करें और आपको बेनिफिट होना चाहिए कि आप इंडिपेंडेंट सॉल्विंग कर सकते हैं। दैट इज़ द मेन मोटिव। बाद में it is only thing is that you need to devote time and practice more and more questions, that's it। तो चलो, तो अब अपार्ट फ्रॉम द डेली ज्ञान सरमन, let me take down to you to the polar form of double integration। polar form double integration, okay, or rather, yeah, okay। Now see, in polar form there is this, okay, I hope the things are visible to you. The screen is clearly visible, otherwise we will uh, shift to PPT and write down there. Now see, आपको I hope everything is visible. I can see there on the screen. Okay. Yeah. Anyone, whoever is joining in, please ask everyone to join as soon as possible so that they do not miss out any bit of it and they enjoy the entire lecture. Maybe I'll just put a call for them that join. Yeah. Okay. So here we begin. The polar form. See, the basic idea of polar form is that you convert your Cartesian coordinate system integral so that you can solve these things easily. Okay, so that is the main idea. Now this is a facility, it is not a big uh, you know stiff method नहीं है. It's a facility. Now when you use this, there is a process that you have to use. So the first thing is in Cartesian system, so what happens in polar rather, so to go from Cartesian to polar, the coordinates in polar system, the system, every point rather, every point P is of the form r comma theta. Okay, now what is r and theta? So the relationship between Cartesian uh, coordinate coordinate system and polar system is like this. First is you have x equal to r cos theta and y equal to r sin theta. Now see, this is the most standard relation that you have here, and you need to be very clear about it. Okay, so this is how it will look like. Just a minute. Is the screen clearly visible to all of you, or is it posing some problem? Yeah. Is the screen clearly visible? आप लोग मुझे ज़रा बता सकते हैं कि क्या क्लियरली दिखाई दे रहा है? In the comment section, can you let me know? Everything is clearly visible. So now I'm writing down everything on my screen. I hope it is visible to all of you. Okay. 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 ठीक है. तो x इक्वल्स टू आर कॉस थीटा और y इक्वल टू आर साइन थीटा, ये मेन रिलेशनशिप है कार्टेशियन और पोलर कोऑर्डिनेट के बीच में. तो इन दोनों का रिलेशनशिप का ग्राउंडिंग एक r के लिए ऐसा है कि एक्स स्क्वायर प्लस वाई स्क्वायर इज इक्वल्स टू आर स्क्वायर. ओके, ये फर्स्ट एक रिलेशन ऐसा दिखेगा इसको. और दूसरा है थीटा के लिए tan इनवर्स y बाय एक्स, tan इनवर्स y बाय एक्स रहेगा. और ये सेकेंड थिंग. और हमारे पास जो डी एक्स डी वाई है, ये और अब जो बोलते हैं डी वाई डी एक्स, ये जो डिफरेंशियल है, ये कन्वर्ट हो जाएगा आपका आर डी थीटा में। ओके, पोलर कोऑर्डिनेट में हम लोग जनरली डी आर डी थीटा, मतलब डी थीटा ऑर्डर ही लेते हैं। वी डू नॉट टॉक अबाउट this is the order which we follow. Okay, there is we do not push people to go for d theta dr. There is a order, but we don't get those kind of complications here. Okay, this is the order, the standard order, r dr d theta. R is the extra term that you need to write. Okay, this extra term comes here, and how does that come? That is due to Jacobian. We will not bother about it. वो कहाँ से आया, हम उसके बारे में ज़्यादा स्टोरी में नहीं जाएंगे डिटेल में अभी। ओके, तो ये एक आपको याद रखना है। अच्छा, अब इसमें लिमिट्स कैसे ढूंढेंगे, मैं सम कराते कराते आपको उसका ये करवाता हूँ। along with the sum which is there, we will see what is the method, how to find the radius limits and how to find the limits of theta. Okay, that will be very helpful to all of you, and this will guide you through the solving of the questions. ठीक है, तो yeah, let me take up the sum now. So let's take up this sum. This is very easy question and very simple question here I am taking. That is, let's say question is change to polar coordinate system and evaluate the integral. ये बोला है, तो कैसे करते हैं देखिए। क्वेश्चन है I इक्वल टू इंटीग्रल 0 to a इंटीग्रल 0 to square root of a square minus y square dx dy. A very simple question for beginning and very easy question. तो आपको कभी भी ऐसा क्वेश्चन आए तो आपको डरना नहीं है। सबसे पहले आपको लिमिट समझ लेना है और डायग्राम ड्रॉ करना पड़ेगा थोड़ा सा क्लियर अंडरस्टैंडिंग के लिए। तो स्टेप नंबर 1 रहेगा अंडरस्टैंडिंग द लिमिट्स विच आर गिवन. सो लिमिट्स ऑफ गिवन लिमिट्स of x are x equal to 0. This is y axis, right? This is y axis. Now next is x is equals to positive square root of a square minus y square. Okay, so let us see what happens to that. And yeah, let us see here. So this is x square plus y square equals to a square. Alright, this is what you get. So this is therefore this is the circle which implies it is a circle. It is a circle centered at origin. I'll just write O0, 0 and radius a. Okay, that is what is the thing. Now what you do, let us see what will happen further. We'll wait for that part coming. Now I'm writing here to the next only I'm writing here. Then what about y? Given limits of y are y equal to 0 which y equal to 0 means you have x-axis, and y equal to a. Now this is the straight line. Okay, we will see regarding that. Okay, so now we will try to draw the diagram. Okay, so I'm drawing the diagram over here. So let us see diagram I'm taking here. So you have your x-axis, then there is the y-axis. All of you, when you are drawing the diagram, I strongly request you that you people draw a appropriate and a proportionate diagram. Please carry a stencil in examination so that you people do not miss out the accuracy of your diagram. You need not take the compass and all that. It's okay for this drawing compass and all, it's not too much required, but take a stencil, draw a proper circle, or even if you are drawing a freehand diagram, please see to it that it is a proportionate diagram. Many times children draw wrong diagram, like जब भी सर्कल बनाना है तो डायनासोर का अंडा बन जाएगा. It's not looking good because you are already having some drawing subjects which are uh, absolutely crucial for engineering. Okay, so making a sense of every object which is in geometry, yeah, I request that it should be correct. Okay, otherwise please use stencil carefully if you are not comfortable drawing freehand. Okay, so that, and don't too much you know, keep your diagrams very loose or shaky, because that doesn't lead to a correct answer most of the time. So now the next is the circle we have. So okay, so I'm just taking the circle here. Now see, I am using I'm on the computer, that's why I have this facility. So I'm using up this facility. Yeah. So yeah, this kind of circle we have drawn. Now the radius is a, this is origin here, and the radius is a, here it will be minus a, and there will be minus a. This is x-axis and this is your y-axis, x dash y dash. Okay, now the problem comes, which region is to be shaded. So while shading of the region, you need to be very careful. So see, the limits which are given to you are given for y equal to 0 to y equal to a. Now remember that these limits in the outer integral. Okay, the outer integral outer integral limits. Okay, these limits, outer integral limits, these limits are are called projection limits. Projection limits. And what do they help you to detect? They help you to detect in which region your area of or the in which portion is your shadow of the region of integration falling. So 0 to a, they are the limits of y axis on y, right? So 0 to a is this region. Okay, this is the part you have the shadow falling over here. So now how do we go about it? So now which part of the circle we are supposed to shade? So now it is very obvious, because the shadow is falling here, either the region of the integration is this one or this one of the two is the correct answer. So detecting the correct answer, the correct region, is very important over here. So now let us see what is it saying? It is x-axis equals to 0, and now here it says it is the positive part of the square root, right? Here can you see here that x equals to square root of a square minus y square. This is a positive square root, so it means that here the region x values are going to be always positive. So here the region of integration that we are going to have is the region number 2. Okay, that's the region of integration. I hope you are clear on this. So here the region of integration is this. Okay, so we have shaded the region. Now it is the quarter region of the circle. Okay, now comes the part to convert to the polar coordinate. This is the time your integral gets converted into polar coordinate once you have detected the region of integration. So if you want to write, you can write here that let it call d, and you can write here the d uh, is the shaded region of integration. Shaded region or the region of integration, or rather you must write like this: the shaded region d, shaded region d is the region of integration. That would be a proper line. Okay, is the region of integration. Now here you have got the diagram, here you have got everything. After this, now we convert to polar coordinate. So in polar coordinate, what happens is that we write down, so let x equals to r cos theta, y equal to r sin theta, and you need to mention all those things. Okay, therefore x square plus y square is equals to r square. Now you already had something similar here. Okay, so call this as 1 and call this as 2. This is 2. Okay, so from 1 and 2, what do you get? From 1 and 2, what are you going to get is r square is equals to a square. Okay, therefore r is equals to a. Okay, now r equal to a, what does it mean? This means this here, I'll just write here, this represents presents equation 1 in polar form. Okay, this is the equation of the circle in the polar form. You need not write all this thing in your exam, but this is for your understanding I am giving you. So what you need to write, the pink one you need not write, it is just for your understanding. So r is equals to a is the circle equation. So now I am just mentioning there that this equation is r equal to a. Okay, so we did that. Now we will go for finding the limits. So yeah, and theta is tan inverse y by x and all that. Yeah, we will see how to handle all this stuff. So see, here it will become I equal to, now you can also mention that thing that dy and all that will become, yeah. So we mention here that dy what is given to us, dx, yeah, dx dy will change to r dr d theta. Yeah, you mention this here, and now we can write here, therefore I equal to double integral r dr d theta. Now, in order to calculate the limits for radius, what you need to do, see. So, I'll just do here one thing. So, I'll take this orange color line. For calculating the limits of the radius from the origin, you pass a ray passing across the region of the integration. You see, you draw a ray from the origin passing across the region. Okay, from the origin it will start and it should pass across the region. Where does it enter and exit the region? That is the limits. That those are going to be the limits. Okay, so you can see the entry point is the origin, exit point is the circle equation, right? So what we will do now, so the limits of r are going to be r equal to 0 to r equal to a. These are the limit. Now regarding theta, what you need to do, see here, for theta there is this nice thing happens is this way. Okay, yeah, for theta what you need to do, you need to draw a arm like this one ray you keep. How एक घड़ी के अंदर एक ऐसे काटा कैसे रहता है, the arm of a watch, like this. You need to imagine like this an arm moving from the origin over. You have to sweep an arm like this from the origin till the region is ending. So like this, see. So this arm goes from 0 to 90 degrees, right? So like this, when you imagine, sweep the arm like this in your mind. So what are the limits that you see? Sweep a arm. So the moment you sweep this, ऐसे एक घुमाओ इसको ऐसे दिमाग में, या तो एक पेन रखो और पेन रख के ऐसे घुमाना है, रोटेट करना है, तो कहाँ से कहाँ तक गया वो? 0 से π/2 तक गया, बराबर? तो 0 से π/2 तक गया है, मतलब थीटा का लिमिट 0 to π/2 आया, ठीक है? ये आपको ऐसे करना है. सो थीटा का लिमिट है, थीटा गोइंग फ्रॉम 0 to π/2. आई होप आपको समझ में आया ये. सभी जन, आप लोगों को ये समझ में आया? बताइए, आपको ये समझ में आया क्या? Comment में like या give a thumbs up or something, so that I can understand whether you are following it or not. Yes, we have got one reply of one student is following. What about others? Please, all others also let me know, so that I can guide you if you don't understand here. See that animation part which I tried to show you over here, this is very crucial. It helps you to understand a different aspect. Okay, so this is how you set up the integral. And if you want to write here, you can mention it. See, it's not compulsory, this is an optional step. Here on above this you can write here that theta went from 0 to π/2, that you can mention here. And here you can mention that radius went from 0 to a. Okay, the radius went from 0 to up to a. This is what you can mention. It's not compulsory. Okay, it's an optional step. So yeah, so yeah, you are just exclusively mentioning the limits over there. So now this is from 0 to π/2. The radius, what is the equation that you have? R square, yeah, the integral is going to be r square by 2 0 to a. Now this is d theta. You get this, okay? So 0 to pi by 2, and here this is a square by 2 d theta. Now when you integrate this, here you will again, huh, great. Thank you for replying over there. So I can, help you out better. So thank you. So here the limits of theta, if you are going to take a square by 2, here then there is you will have pi by 2 over here. So answer is pi square, pi a square by 4 is the final answer of the integration that you get over here. Please hit like so that you understand, I come to know. And yeah, so there are very few people who are joined today. So later on they will get to know the different answers and questions which are there. Okay, now see, let us take up some another questions which are very useful in exams, final exams that you see. So let me guide you with some other questions. These are the questions which uh, uh, most of the students, generally they come in the examination. These are the type I expect in the final exam to be there. Okay, so let me guide you through those. ओके, आप मुझे बताइए कि आपको लिखा आप लोगों ने पूरा प्रॉब्लम लिख के हो जाए तो मुझे बताना, तो मैं फिर दूसरा प्रॉब्लम आपके लिए स्टार्ट करता हूँ. ठीक है, लिख के हो गया है. तो चलिए अब हम अलग प्रॉब्लम लेते हैं यहाँ पर, पोलर कोऑर्डिनेट में कन्वर्ट करने वाला. और इससे आपको ज़रूर फ़ायदा होगा समझने में कि कैसे कैसे अलग अलग क्वेश्चंस आ सकते हैं एग्ज़ाम में. ओके, चेंज टू पोलर कोऑर्डिनेट करना है, तो देखते हैं कैसे करते हैं. तो देखिए ये सबसे इजी एक और अच्छा क्वेश्चन है. तो देखिए क्या करेंगे. तो जैसे कि ये लेते हैं क्वेश्चन. आई इज राइट डाउन द क्वेश्चन, चेंज टू पोलर कोऑर्डिनेट. पोलर कोऑर्डिनेट एंड इवैल्यूएट. तो इसमें अब क्या करेंगे आप, तो देखिए कि इसके लिए आपको, जैसे कि यहाँ पर क्वेश्चन है आई इक्वल टू इंटीग्रल 0 to 2 इंटीग्रल हाँ इंटीग्रल स्क्वायर रूट ऑफ 2x माइनस एक्स स्क्वायर और स्क्वायर रूट ऑफ एक्स स्क्वायर प्लस वाई स्क्वायर dy dx. See, weightage of these modules, see what I'll tell you regarding the weightage. तो वेटेज तो अप्रॉक्सीमेटली अभी कम हो गया होगा ना, तो मोस्टली 15 मार्क्स जितना होगा. मैक्सिमम 15 मार्क्स ऑफ डबल ट्रिपल इंटीग्रेशन आई एक्सपेक्ट. पर उनके ऊपर डिपेंडेंट है कि वो लोग कितना ज़्यादा पूछना चाहते हैं, हाउ मच दे वांट टू आस्क. ओके, इट डिपेंड्स अपॉन देम. सो अगेन वी राइट डाउन here the given limits of y are, what are the limits? Y equal to 0 and y equal to square root of 2x minus x square. These are the limits. So now let us see how to handle this one. um, so here it is a circle basically, but what kind of circle, let us see. So here it is x square minus 2x equals to 0. Now when you add 1 over here, x square minus 2x plus 1 equal to 1, when you do, so you come to know that this is y square plus x square. Here basically this will be x minus 1 the whole square, and this is 1. So you have x minus 1 the whole square plus y square equal to 1. Now it's a circle centered centered at, now let me take a point, centered at a point a 1 comma 0 and radius r equal to 1. Okay, this is the radius over here. Mostly 15 to 15 marks. Okay, maximum 15 marks I feel so, otherwise along carrying the options. Okay, इससे ज़्यादा का तो मुझे नहीं लगता है कुछ पूछना चाहिए, बाकी भी क्योंकि बाकी भी टॉपिक है, वेटेज उनको भी है ना. तो हियर सेंटर्ड एट दिस एंड रेडियस आर इक्वल टू 1. ठीक है, तो ये हम लोगों को इसमें से पता चला. नाउ y इक्वल टू 0 का मीनिंग तो आपको मालूम ही है कि यहाँ ये x एक्सिस होता है. ओके, x एक्सिस है. ओके, अभी लिमिट्स ऑफ y इक्वल y के लिमिट्स हो गए, तो गिवन लिमिट्स ऑफ x, गिवन लिमिट्स ऑफ x आर 0 to 2, x equals to 0, x equal to 2. तो ये तो स्ट्रेट लाइंस है दोनों, तो पर ये प्रोजेक्शन लिमिट से, ये याद रखना आप लोग हमेशा. तो अब हम डायग्राम बनाने के लिए जाएंगे, तो मैं डायग्राम बनाता हूँ यहाँ पर, तो आप लोग भी डायग्राम अच्छे से बनाइए. डायग्राम इज़ द करेक्ट डायग्राम with correct notation, everything gives the examiner a clear understanding whether that the student has understood the concept properly. uh, that means the student has a sense of what he or she is writing. Okay, so after this there is the circle that we are going to take, so let us see. Yeah, so thus for the circle, so the circle is centered at 1 and radius is this. Okay, so here it will be the center at 1, and yeah, I'll just shift this line a bit. Here it's going to be tangent. Yeah, so here is the radius and this is a circle. Now here there is 2. So what does this mean? What is the region of integration? Now this is a question, which is the region. So first see, the given limits of x are from 0 to 2. That means you have to check your region is either the bottom one, either 1 or this 2. Okay, these are the two regions, because it is in between the circle. Because it is in between the circle, so what we will have is either one of the two regions are the correct region. So which one is the correct region? Because y is positive, the upper semicircle is the region over here. Okay, the upper semicircle will be the region. Are you clear on this? So the upper semicircle, this is the region of integration. Are you clear on this? Now, finding the limits for radius, we will see how to handle for radius as well as for the theta. So let us see. So let x equals to r cos theta and y equal to r sin theta. Okay, therefore r square equals to x square plus y square. Okay, this is what you have. Okay, now let us see what is the equation that we had here. These are the various forms of the circle equation, right? So I'll consider this equation which when we solve, okay, this one and the second one, this two. Why did I consider the first one? You can consider any. At the end you will have to open up the bracket and simplify it to this form only. So आई एम कंसिडरिंग द फॉर्मेट जिसमें से हम लोगों ने सॉल्विंग स्टार्ट किया था, तो वो सॉल्विंग वाला फॉर्मेट वो इक्वेशन वन वाला है. ओके, तो मैं वो स्टार्ट करता हूँ. तो यहाँ से क्या मिलता है? तो फ्रॉम वन एंड टू, फ्रॉम वन एंड टू व्हाट डू वी गेट? तो एक्स स्क्वायर प्लस वाई स्क्वायर आर स्क्वायर हो गया, बराबर. आर स्क्वायर और माइनस टू एक्स, माइनस टू एक्स का क्या करेंगे? इक्वल टू ज़ीरो. तो x का वैल्यू देखो, आर कॉस थीटा है, देयर फॉर आर स्क्वायर इक्वल्स टू आर स्क्वायर माइनस टू टाइम्स आर कॉस थीटा इक्वल टू ज़ीरो. तो r इक्वल टू क्या हो जाएगा? टू आर स्क्वायर इक्वल टू टू आर कॉस थीटा. ओके, और अब आर आर कैंसिल कर देंगे तो r इक्वल टू टू कॉस थीटा. ओके, तो ये जो है ये आपका इक्वेशन. सो दिस इज द इक्वेशन ऑफ सर्कल इन पोलर फॉर्म ऑफ गिवन सर्कल, रादर गिवन सर्कल इन पोलर फॉर्म. ठीक है, ये हो गया r इक्वल टू टू कॉस थीटा. समझ में आया आपको? बताइए, आपको ये कन्वर्जन समझ में आया? मुझे बताइए, आर यू एबल? ओके, बाकी लोग जो लोग देख रहे हैं, आपको समझ में आ रहा है? ओके, ठीक है, अच्छी बात है, आपको समझ में आया. ग्रेट. सो आई एम गोइंग फर्दर. नाउ वी विल सी फॉर थीटा. थीटा के लिए मैंने आपको क्या बोला कि अब हाँ, तो आर का हम लोगों ने आर इक्वल टू टू कॉस थीटा को कैलकुलेट करके दिया. तो चलिए अब हम लोग लिमिट लिखने वाले हैं. हम लोग हमारा इंटीग्रल आई लिखेंगे. क्या होगा? तो सबसे पहले फंक्शन क्या है, फंक्शन देखो, फंक्शन दिया है स्क्वायर रूट ऑफ एक्स स्क्वायर प्लस वाई स्क्वायर। तो एक्स स्क्वायर प्लस वाई स्क्वायर क्या होता है, तो इक्वेशन नंबर 2 से वो आर स्क्वायर होता है। तो हम लोग उसका स्क्वायर रूट ऑफ आर स्क्वायर लिख देंगे यहाँ पर, ठीक है। और डी वाई डी एक्स बराबर, डी वाई डी एक्स वो कन्वर्ट हो जाता है आपका, डी वाई डी एक्स गेट्स कन्वर्टेड टू आर डी थीटा। तो ये हम लिख देते हैं यहाँ पर, ठीक है। तो ये आर डी थीटा हो गया। अभी आर का लिमिट्स लिखना है, तो आर के लिमिट्स के लिए यहाँ पर आप आ जाइए। तो आर के लिमिट्स के लिए क्या करेंगे, हम एक लाइन पास करेंगे ओरिजिन से, रादर एक रे पास करेंगे, नॉट अ लाइन, यू पास अ रे फ्रॉम द ओरिजिन passing across the region of integration. Where does it start? It starts from origin. तो एंट्री पॉइंट आपका यहाँ पर ये रीजन में भी ओरिजिन ही रहा, नो प्रॉब्लम, ओके। तो यहाँ पर ऐसे, और एग्जिट कहाँ पर किया, सर्कल के इक्वेशन पे। तो सर्कल का इक्वेशन हमने क्या ढूंढ के निकाला, इसका सर्कल का इक्वेशन है r इक्वल टू 2 cos थीटा, बराबर। तो एग्जिट पॉइंट आपका रहा 2 cos थीटा, ओके। सो यहाँ पर आपका आंसर आया, लिमिट्स ऑफ आर बिकम आर इक्वल टू 0 टू 2 cos थीटा। ये समझ में आया। अब हम लोग थीटा का लिमिट्स निकालेंगे। थीटा के लिमिट्स के लिए क्या हो जाएगा देखते हैं। तो थीटा के लिमिट्स के लिए आप एक यहाँ पर ये इस तरीके से एक रे आपको इमेजिन करना है। आपका पेंसिल या पेन जो भी आपके पास डिवाइस होगा, उसको इस तरीके से रीजन के ऊपर से रोटेट करिए, रोटेट करके खाली ऐसे घुमाइए, देखो क्या हो रहा है, कहाँ तक जा रहा है, पूरा ओरिजिन पे रखो और करो। एक उसको ओरिजिन पर रखिए वापस वो रे को, और आप उसको ऐसे घुमाइए, ओरिजिन पे रख के ऐसे घुमाइए, तो आपको देखने को मिलेगा कि वो आप स्टार्ट हो रहा है, और आप उसको ऐसे नहीं घुमाना है, रुको मैं बताता हूँ। यहाँ पर ओरिजिन पे रखिए, वो ओरिजिन पे आ ही नहीं रहा है, ओरिजिन पे रख के ऐसे घुमाना है इसको। तो रुको, ये तो अलग ही हो गया। हाँ, ऐसे रखिए आप और ऐसे घुमाइए उसको, देखो 0 से 90 डिग्री जा रहा है ना, 0 से 90 डिग्री, समझ में आ रहा है। तो यहाँ पर लिमिट आपकी बनी 0 से π/2, थीटा की लिमिट क्या बन गई, 0 से लेके π/2, ठीक है। तो 0 से π/2 आप ये करें, यहाँ पर लिमिट समझ गए क्या लिमिट के बारे में, ठीक है। तो अब आप यहाँ पर इंटीग्रेशन कर सकते हैं। तो इंटीग्रेशन करते समय i इक्वल टू 0 टू π/2, अब यहाँ पर कितना आएगा, 0 से 2 cos थीटा, यहाँ पर r इंटू आर डी थीटा, ओके। ये r स्क्वायर रूट में से आया है और ये r पहले से ही फॉर्मूला में था। तो अब आप इसका इंटीग्रेशन करिए 0 टू π/2, अब ये हो गया आर स्क्वायर 0 टू 2 cos थीटा यहाँ पर, और आर स्क्वायर डी थीटा। तो अब जब इंटीग्रेशन करेंगे तो 0 टू π/2, यहाँ पर r³ 3 0 टू 2 cos थीटा डी थीटा हो जाएगा। अब आपके पास यहाँ पर जब आप सब्स्टिट्यूट करोगे तो 8 सॉरी, 0 to π/2 तो बाहर रहेगा ही, पर अब आ जाएगा 8/3 cos³ थीटा डी थीटा बराबर 8/3 cos³ थीटा डी थीटा मिल जाएगा। तो 8/3 बाहर ले लीजिए। अभी देखिए, बहुत सारे बच्चों का कंप्लेन रहता है कि सर हम लोगों को cos³ थीटा का फॉर्मूला याद नहीं है। तो या तो आप cos³ थीटा का फॉर्मूला डिराइव करके करें, वो एक तरीका है, या तो अब आप बीटा फंक्शन यहाँ पर यूज़ कर सकते हैं। तो रिकॉल करें, रिकॉल द फॉर्मूला बीटा फंक्शन का। इंटीग्रल 0 to π/2 साइन रेस टू पी थीटा कॉस रेस टू क्यू थीटा वाला फॉर्मूला जो है वो बहुत काम का फॉर्मूला है। तो साइन रेस टू पी थीटा कॉस रेस टू क्यू थीटा डी थीटा, इसका फॉर्मूला है हाफ बीटा p+1/2 q+1/2। ये बहुत काम का फॉर्मूला है। तो अब यहाँ पर आप वो फॉर्मूला यूज़ कर सकते हैं। तो 8/3 इंटू 1/2 बीटा फंक्शन हो जाएगा। तो ये हो जाएगा, p तो 0 है तो हाफ हो गया, और q आपका 3 है तो यहाँ पर 2 आ जाएगा। 3+1/2, 3+1 4, और यहाँ पर डिवाइड बाई 2 है तो 4/2 2 हो जाएगा। तो यहाँ पर 4/3, और बीटा फंक्शन का फॉर्मूला अब आप, हाँ हाँ, वेलकम वेलकम, बहुत समय के बाद। ठीक है। अ, ये हमारे स्टूडेंट कम फ्रेंड सब मिक्स हो गए हैं। चलिए, चलिए, अम, आइए। तो अब यहाँ पर बीटा हाफ और 2, तो इसको क्या करेंगे आप, गामा हाफ और गामा 2। you need to use the relationship between beta function and gamma function, so here it will become gamma हाफ प्लस 2, तो ये गामा 5/2 बन जाएगा आपके पास बराबर। तो यहाँ पर 4/3, और गामा हाफ इज़ √π, और ये गामा 2 इज़ 1। यहाँ पर नीचे आप देखिए तो कितना हो जाएगा आपके पास, ये हो जाएगा 5/2 हो जाएगा। तो गामा 5/2 का वैल्यू कितना स्टार्ट होगा, 3/2 गामा 1/2 और √π बराबर। तो यहाँ से ये √π कैंसिल, यहाँ से 9 हो जाएगा, और ऊपर जाके ये 16/9 आंसर आएगा आपके आई के लिए। ठीक है, तो आपको ये आंसर मिलेगा। ओके, योर प्रेजेंस इज अप्रिशिएटेड, थैंक यू फॉर ज्वाइनिंग इन आफ्टर अ वेरी लॉन्ग टाइम। एंड ओके, so this is the question. Now see, we have solved two questions manually. Now I am going to show you some different and difficult questions which are there, and they can be little bit bothering also at times, but yeah, we will be tackling down them. So I am going to show you those two questions which some of you must have missed out during your events or some kind of classes that were scheduled during the events. So please, means during the events, parallelly some classes were also going on, and some children had a lot of work of their projects, etc. So they couldn't attend due to XYZ reasons. So never mind, here you have a chance again to attempt and see all the things that you have missed out. So technology is a blessing, so you can yeah. So now I am going to show you the PPT over here. So um, so yeah, this is the PPT I'm going to show you. So let me know if you find any difficulty. and any problem. So yeah, here are some questions along with which I had done for most of the students. So yeah, so let us start the PPT and understand how to get this whole thing done. So the question says, sketch the region of integration and convert the integral to the polar coordinate and evaluate it. Okay, so you will need to integrate and evaluate in the following manner. See, the question is very different and very uh, much which does come in some of the examination. Now I do not expect extremely difficult question this year, but since it is the first time of your new syllabus, so let's prepare holistically and let's understand the whole process so that you really benefit from it. Okay, so let me see how does it come to you. So the question says, sketch the region of integration and convert the integral to the polar coordinate and evaluate. So you will need to integrate and evaluate in the following manner. See, the question is very different and very much which does come in some of the examination. Now, I do not expect extremely difficult question this year, but since it is the first time of your new syllabus, so let's prepare holistically and let's understand the whole process so that you really benefit from it. Okay. Holistically, holistically, and let's understand the whole process so that you really benefit from it. Okay. Now I just see there is some problem happening with the slideshow. So I'll just hold on for a moment. What I'll do, I'll see whether if it's possible to just on the this one there is source capture. So display capture and then PPT. Yeah, display capture and the PPT I will have to, yeah, but then it is just capturing the entire PPT. I do not want to oh, yeah, go for that entire PPT right now, but I want to show you the animation along with it. So step by step the thing is there, and so I hope it fits you the best and you will be able to, but never mind. But then that slideshow which is there, that would, if if it comes, then it's good. It's not showing you the slideshow, but it's rather taking up you to the screen part. No, it's not what I expect. No, this is not what I expect it to do. Just a minute. I otherwise what I'll do, I'll take up the question and I'll write down the question the other place and we will solve rather than not taking the PPT. I'll solve the question manually. That would benefit you better. So I'll escape from here and I'll take a snip of this. I think there is some RAM issue happening, but yeah, let it be. Okay. So yeah, so this is a question here, and let us see how to go about it. I'll I think I will have to switch off the PPT first. Then only it will go down. Okay. Yeah. So we have pasted the PPT here, and let me now guide you with the diagram and etc. and everything. So see, this question is a bit special. Why? For the reason. A very very good morning to you. Um, so yeah, so we are already at 10:34, and let me complete it the further part. So see what is now here. uh, Let us understand, the region is in the first quadrant bounded by so and so circle, and this line y equals to x, so region is below that line. So understanding this, so let us first draw the circle. Consider x minus 1 the whole square plus y square equals to 1. So if I open up the circle expression, so firstly it is clear that the center is, let's say, a 1 comma 0, and the radius is 1. Okay, that's clear. So x square minus 2x plus 1 plus y square equals to 1. Okay, and therefore x square plus y square equals to 2x if I write. Now obviously, if you let this 2 go to polar, let x equals to r cos theta and y equals to r sin theta. Okay, so what you get is nothing but, here you will get r square equals to x square plus y square. So therefore you will have r square equals to 2 r cos theta, like the previous problem. It's the same equation, only thing is what is new now, that a straight line has been entered over there. Okay, so that's what you have now. Let us see what shape does this come out. So here we have this straight line, yeah, kind of long elongated straight line, a bit long. So you have this straight line here, and another thing, x-axis and y-axis when I am drawing here. So this is the line, but those arrows, yeah. This is how the straight line looks like. Now it is the region, this is a circle as we had seen previously. So so it's a circle of radius 1. Okay, the radius is 1, and so the center will be here 1 and 0, and this is 2. What they have said is the region is below the straight line y equal to x and the circle, okay, in the first quadrant. So y equal to x line is a 45-degree line. We will need to draw that line as well. So let's draw that line, and that line will be somewhat like this. Okay, it will pass from the origin. Okay, and this will be the point. Yeah, like this. Here you will have the point. I just draw drew it. So you have that point line over there, and y equal to x. Okay, yeah. So now, what is the region of integration that they are asking? It is in the first quadrant, bounded by x minus 1 the whole square plus y square equals to 1, and below the line. So the region is basically this one. This is the region. Okay, that's the region of integration. Over here. Now, let us see how to find the limits and everything. So, for finding the limits, it's going to be a little bit task for theta. Let us see how to get that. Okay. Now, see, first is this one. Here, for limits of radius, not an issue. That would be very easy. We will be able to get here. Limits of radius, what you need to do is you just draw a ray passing across the region. Okay. So the ray has started from origin. It is exiting the circle. Okay. So not an issue. So limits of radius, I'm now exclusively writing for limits of radius. They are going to be 0 less than r is less than 2 cos theta. That's the thing. But for what about the limits of theta? Limits of theta are going to be a bit problematic. We will have to see how to calculate this. Now see, theta, if you try to keep a arm over here, okay, if you draw an arm and rotate it like this, it is just going up to this 45-degree line. Okay, so as you now know, it's not going full, it is just up to this 45-degree line. You cannot go complete up to 90-degree. So you need to know the angle of y equal to x. So you have to stop here, you can't go beyond. It is only this much is the angle that it is taking. So this angle is up to 45 degree. So what you need to do is mention here the angle theta. So this angle theta we will have to see. So that is basically from 0 to 45 degree. Okay, 0 less than theta less than pi by 4. So for limits of theta, now that could be calculated manually also, but I'll just try to show you here how to do it. Okay, so see, for how do you come to know, because it is to the line y equals to x, the y equal to x line implies it is r cos sorry r sine theta, r sine theta equals to r cos theta. Okay, and now these lines are basically r gets cancelled, and then you have tan theta equal to 1, and so this is theta equal to, okay, theta equal to tan inverse of 1, which is pi by 4. Okay, so the line theta equal to pi by 4 is the answer. Alright, this is what you get. Okay, clear? So this is how you come to know the limits is going to go from 0 to pi by 4. So here you have, so therefore I is going to be integral. Now the 2y was there, right? 2 into y. The function was having y over here in the question. So this is 2 times r. So y is sine theta, right? Sine theta, and r sine theta, right? And so, and dr, you will have dy dx getting converted to r dr d theta. So now the limits of radius 0 to 2 cos theta, and for theta it is from 0 to pi by 4. This is your integral ready, and I believe this is solvable. It's easy for almost everyone to get the whole thing done. So let us complete this. So it is going to be 0 to pi by 4. So 2 times r square, right? R square is going to become r cube by 3, 0 to 2 cos theta, and sine theta d theta. So you substitute there, you will have 8 cos cube theta. So 0 to pi by 4, here it becomes 8, so 8 into 2 is 16, right? 16 over 3 cos cube theta sine theta d theta. This is what you get. Hello, are you all clear with this? Are you all clear with what we are doing over here? Otherwise things will bounce over the head and nothing will come into the mind. Okay, so this is what you get here. Now what you can do is, see, there is this very straightforward thing here, that it is almost a type of a beta function a bit, but instead of pi by 4 you should have pi by 2 over there, but so it is not. Okay, so what I am gonna do is I'm gonna use substitution here, and I'll solve the integral, because that would be the best way. I'll substitute and I'll get into the single integral. So what I'm gonna do is put put here cos theta equal to t. I'll put that, and so I'll be able to get dt equal to minus of sine theta d theta. Okay, and then you can get your answer here. So dt minus dt is equals to sine theta d theta. Okay, now what about the limits? When theta equals to 0, t equals to 1, and when theta is equals to pi by 4, okay, t equals to cos of pi by 4, so you will have 1 over root 2. Okay, that is what you will get. So I is equals to 1 over root 2, 16 by 3. Here you will get t cube and minus of dt. Okay, so here it is going to be 1 by root 2 to t, it's not t, 1. Here it is 1, 16 by 3, t raised to 4 by 4. This is what we get, and now here it is going to yeah, that gets cancelled, and when you solve this you will have your 4 by 3, and here you will have 1 by root 2, yeah, 1 minus 1 by root 2. So 1 minus 1 by root 2 whole raised to 4 will be what you will be getting here. Okay, so now when you simplify this 1 4 over 3, here you will have 1 minus 1 by 4, and this will be 4 by 3 into 3 by 4. The answer is going to be 1. So I answer is 1. Got that? All of you followed this? Those who are there online, have you followed? Let me know, and I will be able to guide you through this. Okay, now there is some figures are there that you need to know regarding the polar conversions. So when you convert some figures, you have these figures coming into the picture. So I'll give you those figures here. These are called cardioids. Okay, they are cardioid. Cardioid, sometimes e is there, sometimes e is not there. Okay, I'll not put the e. Cardioid. Now these figures are having the following equation. The equation is of the form r equal to a into 1 plus cos theta. When you do, you have the figure of this kind. Okay, so I'll just draw that x-axis and y-axis here, and here there is one. If you draw, so this figure is something of this kind. This is the kind of the heart shape that gets created. So what is important to note down, that here it will be a, here it will be a, and here at this point here there will be 2a. That is what is important to note down. Now this is r equals to a1 plus cos theta. Similarly, if you have this same figure, then like if you have r equal to a1 minus cos theta, then the figure flips. Okay, the things are going to be a bit different, so the whole figure the same diagram will be there, but the figure will be opening on the right side. Okay, so the thing is like this. This is the diagram that I would like you to draw. So this is going to be there in your final exam. Most of the time they love cardioids and all their intersections and all. So this is the kind of diagram you will have here. Okay, like a small cardioid, a kidney kind of thing, but yeah, you do have a diagram over here. So this is A, and this is 2A over here. That's the diagram that you need to remember. Now you can uh, put some values of theta and you will get the result of the same. So yeah, now their variations are there. So the variations of the same are as follows. So the first variation is r equal to 1 plus a into 1 plus sine theta. So the variation is a bit different. Now you have to rotate the thing upside down. So here you see this is how the diagram looks like. So the thing is, yeah, I'll draw here. It is like this. So here it is a, here it is a, and here it is 2a. Okay, because it's in polar, it's all about the points, so you need not worry about whether it's negative or positive. You would just draw in this way. Okay, and then there is another equation. It is r equal to a into 1 minus sine theta. So the diagram is like, you just flip this diagram over the x-axis symmetry, and sorry, over the y-axis. Its symmetry is over y-axis, but you flip it over the x-axis. So the diagram looks something like this. I'll draw here. Um, yeah. So the diagram is something like this here. So it is, this is the kind of diagram you have here. Again the same thing, a, and here it is 2a. Okay, so this is the diagram that I wanted to share with you, and there are many diagrams like this in polar, and that's the beauty of polar equations, that when you draw you get those rows and 5 petal 7 petal roses and all. Now that is all, see, because all this detailed part is of calculus is not asked in some exams, or most of the exams, so it's all withered off right now. But if you go for most of the competitive examinations, you do see those questions, and in some of the foreign universities also ask these kind of questions. So yeah, IITs and other universities could ask you, but these are good topics where you really need to think, and yeah, lot of things are there. So that is one diagram, and another diagram that I need to guide you on is Lemnitz-Gate. Now there are versions of this, so I'll guide you for that here. Is this one, the diagram, if you have r square equal to a square cos 2 theta, so here the diagram will look like this. So now the diagram is something like this. It's a symmetric, it's a graph of infinity that most of the time we used to draw. So this is the kind of the graph. So both the loops which are there, they would remain symmetric around the y axis and x axis also. So yeah, so I'll just shift this a bit. It would be here at the center. Okay, and let me make it perpendicular. Yeah, this is how the Leibniz skate look like. Okay, so this is the Leibniz skate diagram that I wanted to share it with you guys, and there are few more variations of it, but let's not worry on that. um, I'll We will do those later. Now the question that I would like you to uh, uh, you know understand and worry about is this. So I'll take up the question here, is this one, and this would be the last question of the day. Or we can, if the time permits, I'll take one or two. I'll guide you with the integral, you can solve it on your own. So the question here I'll give you is, find the area. Yeah, so if, like before even jumping into the area, so let me help you for like area calculation. So whenever whenever the f of x comma y is equals to 1, or f of r theta is 1, the double integral I over the region, okay, the I over the region dr gives denotes uh, is interpreted, rather is interpreted interpreted as the area, okay, as the area of R. Now let us see how is this going to look like. So write down the question here. So this is the area problem. So area problem we are calculating now. So let us see how to do this. Hello, how many of y'all are there? Let us go further about it. Okay, some are gone somewhere, so I'll start with this one. So the question is, find the area of the region that lies inside the circle r equal to a sine theta and outside cardioid r equal to a cos a into 1 minus cos theta. Okay, so first let us see how does the circle look like. So r equal to a sine theta, this will, how to convert this is a circle, what is the center and what is the radius, let us understand how does it look like. So it is r square, you multiply r both the sides, so a times r sine theta, so this is x square plus y square is equals to, here you will have, because you are taking it polar, right? So you already know that x equals to r cos theta, y is equals to r sine theta, so here it is y. Now when you convert this one by completing the square and everything, so this will become x square plus y minus a upon 2 the whole square equals to a square over 4. So here it means that it is centered at point, let's say call it a, it will be 0 comma a by 2 and radius is a by 2, that's the radius. Okay, now let us draw the diagram and understand how does it work. Okay, so diagram is here, yeah, yeah, I have this x-axis, y-axis. Okay, that's quite big, I don't want that big graph. Uh-huh. So a by 2, and then here you have is this. So see the diagram is like this here. Okay, so the cardioid that is there, it's the cardioid which is opening towards the like this way. So it's, um, if I draw the cardioid, it's like this, it's going to open. Okay, and yeah, 1 2 3, 1 2 3, then this is a kind of the cardioid that you have, and the circle which will be there. Okay, the circle is going to come like this way. Rather, let me draw the cardioid once more. It will be somewhat like this. Like this is the cardioid. Okay, and here is the point 2a, and here is this one, and the circle is only this kind. Okay, um, bit smaller, like this is the kind of the circle which we will have here, a bit smaller. Yeah, so this is the diagram that you have. Now see, the diagram when you see here. Okay, so I'll just change the color of this one. No, it's not possible to change, I'll think. Okay, let it be. So here is this cardioid, so the cardioid has this r equal to a into 1 minus cos theta equation, and the circle is having the equation r equal to a sine theta. Now So the region of integration that we have is this one. Okay, this yellow region that we see is the region of integration over here, and that is the uh, portion whose area we are expected to calculate. So how do we calculate that area? So in order for going for that, we will have our double integral setup. The double integral will go from r dr, you will have your r dr d theta, limits of radius when you are trying to calculate. So limits of radius, if we want here, so from origin you draw a line passing out. So the line will be entering at the cardioid and exiting at the circle. So the limits are going to be here, it's going to be a times 1 minus cos theta, and exit is the circle a sine theta. And the limits of theta, you can clearly see that the shaded region is from 0 to pi by 2. So you can go for 0 to pi by 2 directly, you can write down. Okay, so having said that, now I'm going to evaluate this one very quickly because it's a long integral. So but you can do it fast also. So 0 to pi by 2, here it is r square by 2, from here it is a 1 minus cos theta to a sine theta d theta. Okay, so having called out for this integral 0 to pi by 2, here it will become a square sine square theta by 2. Yeah, this is there, minus there will be a square 1 minus cos theta, the whole square over 2 d theta. Okay, so I can take a square by 2 outside. uh, okay, a square by 2 taken outside, 0 to pi by 2, and there is sine square theta over here. That is what you get, and then you can integrate it straightforward, or you can uh, do other way around also. So here you see this integral is 1 minus sine square theta here you have, and then here it is going to be, if you expand it, it's going to be 1 plus 2 cos theta minus cos square theta. Okay, over d theta. Now you can use the formula of beta function over here in order to solve this. So a square by 2. Okay, so this integral you can get using beta function also. So the first one is sine square, you can do the normal way also or the beta way also, whichever way you like. So for sine theta, sine square theta, this is half of beta 3 by 2 comma half. This here it is pi by 2 because one integration you are doing right with theta, so it's pi by 2. Here it is 2 cos theta, so again you can use the formula or you can directly get the answer. It's going to be 2 sine theta, right? Here 2 sine theta from 0 to pi by 2, and here it's going to be half beta, again this is going to be 3 by 2. Yeah, uh, yeah, it's half comma 3 by 2, but the same one, right? Now if you recall the property of beta function, so what is it going to give you is this here. So if you recall the property that beta function, beta m comma n is same as beta n comma m. Therefore what will happen is this will cancel. So here is a square by 2 times minus of pi by 2 plus 2 sine pi by 2 minus 0, right? That's also gone. So sine pi by 2 is 1 and you have your answer here. So it is a square by 2 times 2 minus pi by 2. This is your final answer. So if you wish to simplify, it will give you a square by 4, 4 minus pi. That's your answer over here. समझ में आया क्या ये सब? क्या मैं अकेला ही कर रहा हूँ? हेलो, गुड मॉर्निंग, वेलकम to the one of the best cricketer. Okay, so a very good cricket player. Yeah, so we have done over here, and now just some random questions I'll guide you so that you can calculate their answers on your own, and that will help you to solve the integral. So this kind of questions which are there, you can take up, and that will be easier for you. So now see, I'll be just helping you out to convert to the polar form. So if you now general guidelines I'll give you before even I go to calculate. See, general guidelines are, these are not strict but general, you can be flexible with them. General guidelines. So when to use polar form? Polar form, number one. First thing, the function f of x comma y is of the form, it's not compulsory, okay, general guidelines is of form x square y square or x square plus y square, something like that. Second, the region, this is the main a bit important one, the region of integration, is a circle or a part of circle. Okay, is a part of circle. This is when we generally use polar form to ease out our work, otherwise not a big problem. Okay, then it is not a big thing, but then we do this way. Okay, now what is the next thing here? There is, yeah, having said that, you can try out this, but remember these these are not compulsory cases, compulsory compulsory case, compulsory rules. These are not compulsory rules. Okay, it is just a general idea I am giving you कि कब कब आपको यूज़ करना है पोलर फॉर्म, एक्स स्क्वायर एक ऐसा सब दिखता है तो करने का फॉर्म, और सम फंक्शन ऑफ दिस फॉर्म. ओके, सम फंक्शन ऑफ एक्स स्क्वायर वाई स्क्वायर या एक्स स्क्वायर प्लस वाई स्क्वायर ऐसा कुछ है, तो ऐसा पोलर फॉर्म यूज़ करना बेटर पड़ता है, अदरवाइज पोलर नहीं यूज़ करने का. ठीक है, समझ में आया आपको? इससे भी और टफ क्वेश्चंस भी है, वो हम बाद में कभी देखेंगे कि लोगों को आता है या नहीं आता है, कि इट डिपेंड्स ऑन व्हाट ऑल क्वेश्चंस यू प्रैक्टिस, बिकॉज it's not compulsory, as I said you, that they can give you any kind of region to calculate and you will need to go about it. So that's my take on that. So you will need to solve whatever they will ask you, and it may not be compulsory also, so you will have to be very careful while solving all of those questions. Okay. So generally, yeah, since there is some time is there, I'll do one small question here regarding the polar itself. Let us take one small question regarding polar. Yeah. So now this kind of inside outside things are very popular, and that can bother you sometimes. So I'll do one word problem with that, inside and outside the thing. Okay. So let me help you out with that kind of thing. So, or yeah, these are very popular sums which they ask. So let us see what happens, but then it will consume a lot of time. That's what my constraint is. So I'll just guide you. Let's see. The question is, uh, find the area, find the area of region which is inside the circle x minus 1 the whole square plus y square equal to 1, and outside the circle x square plus y square equal to 1. Now what does this kind of thing give you out? So you have to be very careful over here. So when you are going to draw the diagram, that is the time you will have to remember that how to make the diagram, because that is the place where you will make mistake. Ma, again a nice question. So yeah, let me help you out what will look like over here. I think I have this question solved with me, but let me see first. Yeah, it's with two and all, but not an issue. It's a two part. Okay. So see what happens here in this thing. So if you have the how would the diagram look like? So firstly, this is here. The standard circle will be there. Okay. There will be a standard circle over here. Then there will be another circle. There is some problem. Just a minute. Yeah. Okay. Okay, so this is a circle, and what are they saying is that what is lying outside the circle? So outside the circle, x square plus y square is this region. Okay, it is, this is the region, and which is inside the circle. Again, they are asking you to calculate the region, the area of the crescent kind of thing. Now, this, how do we go about? So this is the nice question which is asked. So what you need to do is you need to calculate the points, and if you understand that this point of intersection is very important over here. So first we convert the equations to polar, and then we will see what will happen. So x square plus y square equal to 1, this will give you r square equal to 1. So it is basically r equal to 1 is the radius. That's the equation of this circle. So r equal to 1. What about this one? This here it's nothing but x square plus y square minus 2x, that 1 and 1 gets cancelled here. So x square minus x square y square equals to 2x. Now this we saw in the previous sum. So this is r square equals to 2 um, times r cos theta. So here it is going to be r equals to 2 cos theta. Now you need to take this one and this together. These two equations you keep together. So 1 equal to 2 cos theta. So the cos theta is equals to 1 by 2. Now cos theta equals to 1 by 2, that means it is cos inverse of half. Cos inverse half is pi by 3. It's 60 degrees, right? So this point which is here, this point P, if I call it, it's going to be 1 comma pi by 3. So now the shaded region and is basically double. If you double up the area from 0 to pi by 3, when the theta will go, okay, if theta, if you want to take here from, if you take here from here to only pi by 3 up to here, only this much. So 0 to pi by 3, and you double the area because the area is symmetric over that x-axis. Okay, so because the region is symmetric, so you will have that. And here the integral, the entry point of the circle, the first circle is entering there, where you will see the entry point is going to be r equal to 1, and the exit point is r equal to 2 cos theta. Okay, 2 cos theta, and the radius that you are taking is r dr d theta. So if you do this, you will get your answer. And so shaded region, yeah, shaded region area is double of this. So 2 times 0 to pi by 3, and here it is r square by 2, 1 to 2 cos theta d theta, and you simplify this. So 2 and 2 gets cancelled. So 0 to pi by 3, it is going to be 4 cos square theta minus 1 d theta. Simplifying this, you will get your integral. Okay, so here it will be 4, and then there will be cos square. When you want to integrate, it will become 1 plus cos 2 theta by 2 integral 0 to pi by 3 d theta, minus here it will be pi by 3 d theta. When you do that, you will get, so here it is 2, and here it is pi by 3 and cos theta integration is going to be sine theta by 2, okay, minus pi by 3. So here it is 0 to pi by 3 are the limits, so substitute those limits. So what will happen is 2 here pi by 3 plus sine uh, 2 pi by 3 you will get here, okay, 2 pi by 3 by 2 minus 0, minus of pi by 3 and 0, so that's a 0, okay, pi by 3. So 0 over here, and here it will be cancelling, so here it will be sine 2 pi by 3 minus pi by 3. That will be your answer. So that's how you get that answer. I hope you understand that, and I'll just calculate that value. So 3, so root 3 by 2 you will get there, okay. So this will be root 3 by 2 minus pi by 3. So let me see that whether the value remains positive, otherwise I just want to confirm that nothing is wrong. Root 3 by 2, root 3 over 2 minus pi by 3. uh, no, there is something error has happened, I feel. Yeah, pi by 3, some kind of mistake, I think so. Just hold on here. Yeah, but this integral when you solve you will get the answer. So 4 cos square, and then here will be 4 cos square, um, right, and then the 2 gets cancelled off, and yeah. Okay, those who are there, so here you have 2 cos theta, then that, and after that what is the area? Yeah, 4, because of that minus root 3 you should get, but I'm getting that a bit different, a bit. Let me check out. Yeah, so that's the circle, right? So from the circle you will have this 2 times 0 to pi by 3, so 0 to pi by 3, 1 to 2, and then here it is 2 cos square theta minus 1, 2 goes away. So here let me see this integral. I'll just take up this here, if I can get here how much is the value. I'll give you the answer. So it's double integral 0 to pi by 3. Yeah, so pi by 3 4 cos square theta minus 1 bracket d theta. Yeah, so answer is going to be, sorry, there's some error must have been there. So yeah, so the thing over there, um, your final answer is this. When you integrate here, some mistake here in the calculation. Just a minute. So here the integral value when you do is 0 to pi by 3 4 1 plus cos 2 theta by 2, right? That's what you get. And here you will get is 1 d theta. So that is basically 4 here. I missed out that 2 for both of them, right? Yeah, I got that. So 0 to pi by 3 2 plus 2 cos 2 theta minus 1 d theta, and this will be 0 to pi by 3 and 2 and 2 this is 1 plus 2 cos 2 theta d theta, and this when you will integrate you will finally get your answer here to be, the answer here it will be 2 pi by 6, rather it's pi by 3 rather, so it will be pi by 3 plus root 3 by 2. That is your answer over here. Okay, so I hope you get this answer and you are able to solve this. So okay, I am already 5 minutes more than the time that I had promised. Thank you for joining in, and I hope you will benefit from this lecture and you will be able to solve as many as problems possible. I know that trend is downward trend, but never mind, you can watch at your ease, and I hope you will like it. So thank you. I'll see you later on uh, in the other portions. Okay, thank you. Okay, so see you then. uh, so you have all these things here, and we will meet later on. Thank you. So, bye bye. We will be meeting later for another class. I don't know, someone is there.